we would understand now how do we perform the experiment on heat pump and what readings we will be taking, what calculations we will be doing so as to determine the performance of a heat pump. By performance of a heat pump, I mean coefficient of performance, COP. What you see over here is there are certain instruments which are provided for taking the readings on the heat pump. Heat pump, we know that it operates on the refrigeration system. It has got a compressor, it has got an expansion device, and it has got two heat exchangers. One is the condenser and other is the evaporator. We get the heating effect in the condenser section. So suppose you want to heat some water from 25 degrees centigrade up to, let us say, 60 degrees centigrade. So we can put that water in this tank, and by operating the refrigeration system we can get the heating effect. This can be done by using a refrigeration system, mind you. So refrigeration system is not used here for cooling, but here we are using the refrigeration system for heating. That is the difference between a refrigeration system and a heat pump. What readings are essential to determine the coefficient of performance? So as the refrigerant is circulating in this loop, we must know how much refrigerant is circulating. How much refrigerant is circulating, this we can note down by taking the reading of this flow meter. So the flow meter, when you start the system, the flow meter, which is based on the simple principle of bioenergy, that flow meter will show certain reading, and you can note down that reading. That would be the volume flow rate. Volume flow rate, if you divide it by specific volume, you can get the mass flow rate of the refrigerant flowing through the heat pump. So the flow meter reading is very important for getting the mass flow rate of the refrigerant. Then we must know the pressure in the system. We know that the heat pump as well as the refrigeration system, it is a two pressure system generally. It has got a higher pressure which is known as the discharge pressure, and there is a lower pressure which is known as the suction pressure. So there are two pressure gauges which would help you determine the pressures in the system. Okay, you know the pressures are given here in kg per centimeter square. That pressures which are given in kg per centimeter square, we need to convert it into bar, and we need to then convert it into absolute pressure. Gauge pressure is converted to absolute pressure by adding the atmospheric pressure to the gauge pressure. Okay, so this way we will get the absolute pressure in the evaporator and the absolute pressure in the condenser by the help of measurement using these two pressure gauges. Another important reading one needs to know is the energy which is consumed by the compressor. So for knowing how much energy is being consumed by the compressor, just as you have electric meters at your home, similarly here you will find an analog meter. This analog meter has a disc which rotates, and it will note down how much is the electricity consumption. So you can note down these readings, initial reading, that would be in kWh, and you can note down after the experiment the final reading kWh2. The difference upon time in hours, that would give you the compressor working kilowatts. So compressor working kilowatts can be found out by noting the initial reading kWh, final reading kWh divided by time in hours. Or there is another method. These compressors are calibrated, so we know the energy meter constant, and then I will give you one formula. From that energy meter constant, you can calculate the power consumption of the compressor by noting down how much revolutions this disc is making. You see that there is a disc, so disc is rotating. So you can take, let us say, you can start your stopwatch and note down the time for 10 revolutions. That time, let us say, is t, and the 10 revolutions becomes your m. Then by using one expression which I will be giving you, you can calculate the power consumed by the compressor. You would also find that there are certain there is a dial gauge over here, and this dial gauge, when you start the system, you will get certain readings here. Those are the temperature readings, and I will show you what temperature readings are taken. The temperature readings help you locate what are the temperatures across the heat exchanger, that is, what is the temperature after the evaporator, what is the temperature before the evaporator, what is the temperature after the condenser and before the condenser. All these temperatures you can note down from this dial gauge. What is to be calculated is the heating effect and not refrigerating effect. So in the heat pump, we are interested in knowing the heating effect. Heating effect can be calculated by a very simple technique. You know what is the mass of the water which is taken inside this? This cabinet has got water in it. The water, and in the water there are coils. So the coil would heat up that water. Okay, this is the condenser coil. It would heat up that water. There is a rise in temperature of that water. Let us say the initial temperature was 25. Finally, it becomes 60. So 60 minus 25 becomes the rise in temperature. Upon time gives you the rate of heating effect. That is the heating effect. MCP delta T upon time upon the power consumed by the compressor would give you the coefficient of performance of this heat pump. Okay, this coefficient of performance can also be calculated by using the pressure enthalpy chart of the refrigerant which is used. Okay, so let us just discuss it in brief using the board. This heat pump, as I said, basically does the job of heating the water. Okay, so it is heating the water. It could heat the room also, it could heat the water also, whatever. Heat pumps which are available in the market today in India, they are used for heating water for bathing. Heat pumps which are available in European countries or in colder climate, they are used for heating the rooms, okay, for the people to be comfortable. So if you want to heat certain space, so that heat is, let us say, QH. So that is your desired effect, and for that you need to run the compressor which will consume electricity. That is your power consumption. So the COP is what? COP is the heating effect upon the power consumed which is W. How do you find the heating effect? As I had shown that mass of the water taken in the tank, specific heat of the water which is 4.187, then the temperature rise. Let us say 60 was final, initial was 25, so 60 minus 25 is temperature rise. Upon the time for heating, that time you can take it in seconds, and if you take it in seconds, Cp is 4.187 kilojoules per kg Kelvin, then your answer would come in kilowatts. This is the heating effect, desired effect. And for finding the power consumed, as I had explained, either you take the kWh1 and kWh2 upon time, or you use this formula. And if I had noted down the time for 10 revolutions, so n becomes 10. Okay, and the time you can note down in seconds, so that becomes your seconds, time in seconds. Okay, whatever time, so 8 seconds for 10 revolutions. Into 3600 to convert the seconds to hours, and energy meter constant, in this case the energy meter constant is 3200 revolutions per kWh. Okay, so if you use this formula also, you can get the power consumption in kilowatts. The ratio of the two, that is heating effect upon power consumption, would give you the coefficient of performance of the heat pump. The other way of doing it is by using the pressure enthalpy chart. Pressure enthalpy chart for the refrigerant which is used. You can find the enthalpies at 1, H1, enthalpy at 2, H2, which is nothing but the enthalpies across the compressor. This is compressor, compression. Then you must know the enthalpies across the condenser because the heat is ejected there. So you must know the enthalpies at 2 and enthalpy at 3. So if you get the enthalpy at 2 and 3, that becomes the numerator. H2 minus H3 is the specific heating effect. This enthalpy minus this enthalpy is the heating effect, and this enthalpy minus this enthalpy is the compressor. The ratio of the two will give you the coefficient of performance of the heat pump. One more important thing is why are we measuring the mass flow rate of the refrigerant? So mass flow rate of the refrigerant, if I want to use in the calculation, that is very simple. What I do is the mass flow rate of the refrigerant, if I multiply it with H2 minus H1, which is the enthalpy difference across the compressor, that becomes my compressor power. Okay, and mass flow rate of the refrigerant, if I multiply with the difference between the enthalpies across the condenser, that becomes my heating effect, QH. Okay, so this becomes the capacity of the heat pump. This is the capacity of the heat pump. The answer would be in kilowatts if your mass flow rate is in kgs per second. And how do you get the mass flow rate in kgs per second? For that we have used the flow meter, and for finding the mass flow rate, we have noted the flow meter flow which is in volume upon we can use the specific volume at point 3 from the refrigeration tables. This will give you the mass flow rate, and this mass flow rate we use in the calculation. So very interestingly, heat pump experiment is similar to your refrigeration experiment. The difference is the heat pump gives you the desired effect as heating effect. It pumps the heat and it maintains the space at a higher temperature than the surrounding. And very simple calculation, very simple experiment to perform the performance trial on a heat pump. I hope that you have followed it. All the best. Thank you.